This is Miss Humbert here. Today we're going to be doing Unit 9, Notes 1. So we're going to be talking about graphing inverse variation. So let's take a look at what inverse variation is. So when we're taking a look at this one, so the number of revolutions of the pedals made when riding a bicycle at constant speed is going to vary inversely at the gear of the ratio of the bicycle. So what does that mean? In other words, as the gear ratio decreases, so if you turn the gear ratio down on your bike, the revolutions per minute increases. This is why shifting to a lower gear allows you to pedal with less difficulty when riding uphill. So you notice when you turn the gear really low on your bike and then you just start pedaling and pedaling and pedaling and pedaling and pedaling? That's an inverse ratio. So basically as one goes up, the other goes down. So that's what we're going to be working on when it comes to inverse variation. So let's go ahead and let's take a look at inverse variation. So y varies inversely as x if there is some non-zero constant k such that x times y is equal to k. So k is going to kind of be like our constant that our two variables x and y are going to be equal to. So let's take a look at an example of one of these problems. So the time it takes to travel a certain distance varies inversely as the rate r in which you travel. So for example, the faster you travel, the less time it's going to take you to get there. The equation r times t, or rate times time, is equal to 250 can be used to represent a person driving 250 miles. So we want to figure out based on our rate, how long it's going to take us. So all we want to do is, so we're having an equation, RT is equal to 250. Okay, so all we're going to do is plug in each of those values for r. So for example, we're going to have 5 times t is equal to 250. All I did was plug in 5 for t. Divide both sides by 5 and I get t is equal to 50. So here t is equal to 50. Same thing for 10. 10 times t is equal to 250. Divide both sides by 10, and I get 25. So really, when I'm filling these out, all I'm doing is dividing 250 by each of these numbers. So let's go ahead and let's do that. So 15 divided by, or 250 divided by 15 is 16.67. 20 divided by 200, or 250 divided by 20 is 12.5. 250 divided by 25 is 10. 250 divided by 30 is 8.33. 250 divided by 35 is 7.14. Divided by 40, 6.25. Divided by 45, 5.56. Divided by 50 is 5. So now what I want to do is I want to actually go through and graph these points. So let's do that. So we're going over 5 and then up 50. We're going over 10 and then up 25. We're going over 15 and up 16.61, which is going to be just above 16. Over 20, up 12, which is probably going to be about halfway. Over 25, up 10, which is about here. Over 30, up 8.33. Over 35, up 7.14. Up 6.15, up 5.1, and then finally we're at 5. So what you'll notice here is we have a graph sloping downwards. And just like with exponential functions, we're never going to cross up here or up here because negative rate doesn't make sense. Going in negative 10 miles per hour, I don't even know what that means. Likewise, negative time doesn't make sense. So we're never crossing those axes. Let's go ahead and let's just take a look at a general problem dealing with inverse variation. So it says that first we need to find the equation when y varies inversely as x, when y is equal to 15 and x is equal to 6. So the first thing we want to do is to write the equation. So to write the equation, what I'm going to do is I'm going to take those two numbers, multiply together, and set them equal to k. So 6 times 15 is 90. So my k is equal to 90. So the graph that I'm going to be doing is xy is equal to 90. So that's the equation that I'm graphing. So now I need to pick my x values. Now when I go to pick my x values, I try and pick values that are going to fit well into 90, that divide 90 into a nice number. So I start with 0 at the center. And then I pick numbers that divide nice into 9. Well, 2 divides 9 nicely, so does 3, 6, and 9. And what I do to one side, I'm going to do the negative version on the other. Okay, so 0 then is undefined. So now what I'm going to do is I'm going to take 90 and I'm going to divide them by each of these numbers. So 90 divided by 2 is 45. 90 divided by 3 is 30. Divided by 6 is 15. Divided by 9 is 10. And then over here I'm going to have the negative versions of all of those numbers. So I'm going to have one side that's all positive and one side that's all negative. And now I need to set up my scales. So since I only get up to 9 on the x-coordinate, I went by 2s. 2, 4, 6, 8, 10. And then since I went up to all the way up to 45, I went by 10s on my x column. So when you change your scale, or on my y column, sorry, when you change your scale, you need to make sure you note it to whoever's looking. So I'm going over 2 up 45. So if this 10, 20, 30, 40, this is 40, then this right here is going to be 45. And then I'm going over 3, which is halfway between, and then up 30. Over 6, up 15, which is going to be here. And over 9, up 10. So there's the one side. Now I need to do the same for the negative side. So I'm going left 2 down 10, 20, 30, 40, and then 45. Left 3 down 30, 10, 20, 30. Left 6, 2, 4, 6, up 15, which is about here, and over 9, up 10. And all of those are negative. When both of them are negative, that's going to be in that third quadrant there. So if you look, if I were to draw an invisible line through here, those two reflect over themselves. So they should be kind of a mirror image of themselves. Next, let's go ahead and let's take a look at number 3. So for number 3, we want to graph inverse variation in which y varies inversely as x when y is equal to 12 and x is equal to 4. So the first thing I'm going to do is multiply 12 times 4 and I get 48. So I have the equation xy is equal to 48. So again, I'm going to put 0 in the center, and then I want to pick values that fit nicely into 48. So I just kind of went and I did 2, and I did 4, and I did 8, and I did 16. If you're not sure what numbers divide it evenly, start in your calculator. Pick numbers that you think make sense and try them. See if you get a whole number. Then I have -2, -4, -8, -16 on the other side. So then your 0 is going to be undefined. Okay, because we can't divide by 0. That's why our 0 is always undefined, because if one of these were 0, we'd have to divide by 0 to get the other one, and that just can't happen. So 48 divided by 2 is 24. 4 divided by 2 is 12. 48 divided by 48 divided by 4 is 12. 48 divided by 8 is 6, and 48 divided by 16 is 3. Then we're going to have the negative versions going down this side. So then we can go ahead and graph that. So what I did is I had my scale go up by 8. So 8, 16, 24. Okay, so if we're going over 2 up 24, that's here, and we're going to hit this line here. Then over 4 is going to be halfway, and then we're going to go up 12. 12 is going to be about right here. Then we're going over 8 up 6, which is going to be right about here, because we're not going quite all the way to 8. Over 16 up 3 is going to be down really low. So this one actually, because of my scale, ended up being really close to the bottom of the graph. Then we're going to do the same for our negatives. Going over -2 down 24, which is about here. Then we're going over -4 up 12, which is going to be probably about right here. Again, I'm just estimating, which is all I'd ask you to do. Over 8 down -6, which is about here. And then left 16 down about 3, which is going to be about here. So we're going to graph that. And again, you're not crossing either one of the axes. Okay? So let's now take a look at number 4. So for number 4, we want to graph an inverse variation where x is equal to 2 and y is equal to 8. So again, we're going to take 2 times 8, and that's going to be equal to k. So our k is equal to 16. So xy then is going to be equal to 16. So in the center, we're going to start with 0, and 0 is always undefined. And then we're going to go, I did evens. Okay, so 6 doesn't work out perfectly. That's okay. If you want to try and graph with a decimal, you can, okay? It's just sometimes easier if you find ones that aren't decimals. So then I'm going to go ahead and I'm going to go to the negative. Oops, I forgot 4. So then we're going over 2 and up 8. And so 48, or 16 divided by 4 is 4. 16 divided by 6 is 2.67. 16 divided by 8 is 2. Then we're going to have the negative. So all I did was I took 16 and I divided each of the numbers by that. So we're going over 2 up 2, 4. So we're going over 2 up 2, 4, 6, 8. Over 4 up 4. Over 6 up 2.67, which is about here. And then over 8 up 2. So again, I did my scale by 2s, so you do want to make a note to who's ever looking at it that it's by 2s, even though that is really difficult to read. And I also went up by 2s for this one as well. So always make note of your scale. Then we're going to do the same for the negative. Left 2, down 2, 4, 6, 8. Left 4, down 4. Left 6, down 2.67. Left 8, down 2. So again, it's going to be kind of swooping this way, never crossing that axis on either side. Okay, let's take a look at this last one here, which is number 5. So for number 5, we're talking about a super fast computer company. And it says that the time T hours it takes to build a particular model varies inversely with the number of people of working. It makes sense, right? The more people you have working, the less time it's going to take you. So the equation it gives us, PT is equal to 12. P represents the number of people, T is the number of hours. And that can be used to represent people building a computer. And now we want to complete the table. So what I'm going to do is I'm actually going to cross these off all together. So instead of using those numbers, I'm just going to count the squares as is. I'm not going to change the scale at all. So I have this equation PT is equal to 12. So I'm going to take 12 and divide it by each of these numbers. 12 divided by 2 is 6. 12 divided by 4 is 3. 12 divided by 6 is 2. 12 divided by 8 is 1.5. Divided by 10, 1.2. Divided by 12 is 1. So now I'm going to go ahead and I'm going to graph these points. So I'm going over 1, 2, up 1, 2, 3, 4, 5, 6. Plot that point. Over 4, up 1, 2, 3. Plot that point. Over 6, up 1, 2. Plot that point. Over 8, up 1.5. So we're going 1 and then we're going halfway to 2. 10 is 1.2, so that's going to be just above 1. And then 12, oops, 10 is here, my bad. 10 is here. And then 12 is going to be actually at 1. So then we're going to go ahead and slope that down. So notice that this one only has the first quadrant. It doesn't have the bottom part of the graph. That's because it's a word problem and negative people and negative time don't make sense. Okay? So that concludes your note video for today. Go ahead and show the substitute once you are finished. Thanks for listening.